chemists are, as we like to call it, the central science, and they always have a lot of contributions to make to everything, society and whatever. I think the challenges are mainly the public still does not recognize chemistry as a clean science, as a science that makes things that are positive. They always associate it with pollution and with so changing the attitude in the population is a big challenge for chemists and continues to be a big challenge. How can we as chemists go out to the population and convince them that chemistry is the central science and it touches their lives on a constant basis? People just don't want to, the regular public doesn't want to accept or understand that reality, unfortunately. So I think that's one challenge. Of course, funding is always a challenge, international and national. So getting more funding for fundamental chemistry, fundamental research, and is always a hassle. As division director for chemistry at the NSF, I fought very hard to try to increase the budgets for fundamental chemistry. And that's always a very difficult thing because you're always competing for money with the other disciplines, physics, and physicists sell themselves very well. And they are still looking for the mass of the universe that has been lost for a long, long time, and they keep doing very well. Chemists think a little bit smaller, and they don't think in terms of big centers and big problems that are going to change the way we do everything. So I would say those are the two big challenges that I see for chemistry as a discipline and for chemists as practitioners of the discipline. It's universal. Chemists, it's a difficult science to sell to people who give the money and to the public in general to support us. But if you say billions and billions of stars and the Big Bang and all this kind of stuff, then the public goes, wow. Astronomy has the same impact on the population. But the problem is that even nano has a bad name, as you know. Remember, there was a book, I forget the title of the book, which is all about nanoparticles assembling themselves and creating all kinds of problems for humanity, right? So even nano, the federal government in the US gave a lot of money for people to research what are the effects if you spill nanoparticles that have never been in nature before, right? What are the toxic effects of nanoparticles on plants? Everything we do seems to always have a negative, toxic side to it, and the public hangs on to that. And chemists are always polluting. Chemists are always doing this. Even nanoparticles, they're afraid of nano. They don't, even if you show that nano can do really well. The American system of evaluation of proposals is probably the cleanest. I'm not going to compare it to anybody else, but it is extremely, extremely careful about conflicts of interest. It's very, very worried about improprieties and so on. And the system works really, really well. I mean, there are no irregularities of people, calling potential reviewers and trying to persuade potential reviewers to help them. The system is very clean, very, very, very clean. So, and I think it works very similar to the way it works here, which means you send proposals out for ad hoc review. So you get reviews, and then you have people making decisions in panels, and the panels are very carefully selected, and people do really, in a way, NSF is almost painfully correct. They don't allow anything to go wrong. So, and I think it's very efficient. Nano has been around for a while, but it continues to be around, and because it is really making progress. I mean, nano is impacting many aspects of practical life and society and the public. So nano is around, and the big problem, as I said at the beginning, is that there is not enough money to go around, right? And what happens is you suffer pain when you have to, out of 100 proposals in chemistry that are received by the chemistry division, you can only give money to 23, right? So you have to eliminate essentially 3/4 of the proposal. That's painful. It used to be back in the 60s, 70s, 80s that the success rate of proposals was closer to 35 to 40%, which is about the right number to have, but it's been far from that for a long time. The budgets have not increased proportionately, and it's really a problem of funding. And I remember when I learned how to do evaluations at the NSF, because I was there before being division director. I was actually a program director much earlier on. And I used to agonize and go to my supervisor and say, oh gosh, this is horrible to say no to this proposal. And he always just look at me and say, do you think you're funding the best proposal? Yep, I think I'm. Okay, then you're doing your job. You know, you cannot worry about everybody. You have to make sure that you're doing your job correctly. So, yeah, it's a tough job. And being division director, of course, I made a comment earlier on, because you're responsible. And if someone doesn't get funded, guess who they don't like? Yeah, energy is big time now, of course, and there are many programs within chemistry and outside of chemistry that cater to photovoltaics, not only energy generation, but energy storage, batteries. So there's a lot of research going on in energy, renewable energy, hydrogen, and so on. It's been around for a while now. And it seems like it's really progressing. I think the catalysis people making a lot of progress in terms of being able to, bring clean energy to cheaper and applications and so on. I don't know if are you aware that the National Science Foundation, the new director, I think it's been 1 or 2 years in that position. He now has a new directorate, which is called, let me see if I remember what it's called, TIP, which I think is technology, innovation, and what is the P for? The P is for partnerships, and is much more applied than NSF. NSF has been traditionally exclusively for fundamental research, not for applied research. And this research in this directorate, which has a lot of money, by the way, is supposed to be not necessarily for fundamental, but use-driven. So you find a problem that needs to be solved, and then you do research, but not necessarily curiosity-driven, which is the way NSF had always operated. So all of a sudden, NSF is moving a little bit away from exclusively curiosity-driven research to more applied research. I think in the States, and I don't want to get into politics at this point, right? Because part of the problem that I see in the States is that our politics are pretty backwards at this point, has been for a long time. And I think that decisions, the US pulled out of the Paris Agreement, right? Which means that there was no conscience of international conscience of we need to be there. Well, we were pulled out of the Paris Agreement. I think that is symptomatic of what's going on in the US. Biden is exactly the opposite of what was being done before. So I think right now that there is a similar thinking in the US as you see in Europe in terms of being sensitive to the needs and the problems and how to solve the problems and how to keep, low carbon economy. I hope that it continues that way. And the question is for how long, right? So that's why I said I don't. I mean, I said I wasn't going to talk about politics, but I ended up talking about politics without naming some people. I think the U.S. is on the right track right now. I think they recognize the need to global warming and all of this. We still have people who don't want to believe in it, but just because they don't want to, or they are very ignorant and they don't know science.